What if I told you that beneath your feet right now, forces more powerful than 1,000 nuclear bombs are constantly reshaping our planet? The ground we walk on isn't as solid as you think. In fact, Earth's formation began with a collision so violent it literally created the moon. And the most terrifying part? These catastrophic geological forces are still active today. Welcome to the untold story of how Earth was forged in chaos, and why the most dangerous chapter might still be ahead of us. The beginning of everything. 4.5 billion years ago, our solar system was nothing but a swirling cloud of gas and dust. But within this cosmic nursery, something extraordinary was about to happen. Gravity began pulling material together, forming a molten sphere that would eventually become Earth. But here's where the story gets truly mind-blowing. Larar Spies. The Theia Impact. During Earth's infancy, a Mars-sized planet called Theia was hurtling through space on a collision course with our young world. The impact was so catastrophic that it vaporized both planetary surfaces. Imagine temperatures exceeding 10,000 degrees, hot enough to turn rock into gas. The debris from this cosmic catastrophe didn't just disappear. It formed a ring around Earth, eventually coalescing into what we now call the Moon. This wasn't just any collision. It was the single most important event in making Earth habitable. Ceres, the magma ocean era. For millions of years afterward, Earth's surface was a global ocean of molten rock. There was no solid ground, no water, no atmosphere as we know it. Just an incandescent sphere of liquid fire, glowing like a second sun in the darkness of space. The planet was radiating so much heat that if you could somehow observe it from space, you'd see a blood-red world, pulsating with the fury of its own formation. When the planet reorganized itself, as Earth began to cool, something scientists call the Iron Catastrophe occurred. This might sound like a disaster, but it was actually essential for life as we know it. Heavy metals like iron and nickel began sinking toward the planet's center, while lighter materials rose to the surface. This process released enormous amounts of gravitational energy, reheating the planet and creating distinct layers: the core, mantle, and crust. Wanchuar, the birth of Earth's magnetic shield. That iron-rich core didn't just sit there. It began to move, creating electric currents that generated a powerful magnetic field, Earth's invisible shield against solar radiation. Without this magnetic field, the sun's deadly radiation would have stripped away our atmosphere, leaving Earth as barren as Mars. This protective bubble is still guarding us today, deflecting millions of charged particles every single second. The discovery that changed everything. For centuries, people noticed something strange. The continents looked like puzzle pieces that could fit together. But it wasn't until the 1960s that scientists discovered the mechanism behind it: plate tectonics. Earth's crust isn't one solid shell. It's broken into massive plates floating on the semi-molten mantle beneath. These plates are constantly moving, grinding against each other with unimaginable force. The Ring of Fire. Nowhere is this more evident than the Pacific Ring of Fire, a 25,000-mile arc of volcanic activity and earthquake zones. This horseshoe-shaped region contains 75% of the world's active volcanoes and experiences 90% of Earth's earthquakes. The forces at work here are staggering. When oceanic plates collide with continental plates, one is forced beneath the other in a process called subduction. The descending plate melts, creating magma that rises to form volcanic mountain chains. The Himalayas. A collision in slow motion. About 50 million years ago, the Indian subcontinent crashed into Asia with such force that it created the Himalayan mountain range. This collision is still happening today. Mount Everest grows about a quarter-inch taller every year. The pressure from this ongoing collision is so intense that it triggers earthquakes hundreds of miles away from the collision zone itself. Ors. Supervolcanoes. The planet's reset button. Beneath Yellowstone National Park lies one of Earth's most dangerous geological features, a supervolcano. This isn't your typical mountain-shaped volcano. It's a massive caldera, a collapsed volcanic crater spanning thousands of square miles. Scientists estimate that when Yellowstone last erupted 640,000 years ago, it ejected enough material to bury the entire state of Texas under 5 feet of ash. The atmospheric effects would have plunged the planet into a volcanic winter lasting years. The Deccan Traps. 66 million years ago, one of the largest volcanic events in Earth's history occurred in what is now India. The Deccan Traps eruption released over 1.2 million cubic miles of lava, covering an area larger than California. The gases released altered the global climate so dramatically that many scientists believe it contributed to the extinction event that ended the age of dinosaurs. The planet was fundamentally transformed. Iceland, where the Earth tears itself apart. Iceland sits directly on the mid-Atlantic ridge, where the North American and Eurasian plates are slowly separating. The island is literally being ripped in two, growing wider by about an inch every year. The volcanic activity here is relentless. On average, Iceland experiences a volcanic eruption every 4 to 5 years. It's a living laboratory for understanding how our planet's internal forces shape the surface. Yanjaos, Pangaea. When all land was one. About 300 million years ago, all of Earth's land masses were joined together in a supercontinent called Pangaea. The climate was extreme. The interior was almost entirely desert, while coastal regions experienced intense monsoons. But Pangaea didn't last forever. The same tectonic forces that created it began tearing it apart about 175 million years ago. Uranus, the supercontinent cycle. Scientists have discovered that supercontinents form and break apart in a cycle lasting approximately 500 million years. Before Pangaea, there was Rodinia. Before that, Columbia. And before that, Kenorland. Each time a supercontinent forms, it fundamentally alters ocean currents, climate patterns, and the evolution of life itself. Pangaea. Ultima. The next supercontinent. Computer models predict that 250 million years from now, the continents will merge again, forming a new supercontinent. Some scientists call it Pangaea Ultima, others Amasia. The Atlantic Ocean will close, pushing the Americas back into Europe and Africa. The Mediterranean will disappear completely, and a new mountain range, potentially rivaling the Himalayas, will form along the collision zone. Chapuis. The power. Locked in faults. Earthquakes occur when stress accumulated over decades or centuries is suddenly released along fault lines. The most powerful earthquakes can shift entire cities several feet in seconds and alter the planet's rotation. The 2011 Tohoku earthquake in Japan was so powerful that it shortened Earth's day by 1.8 microseconds and shifted the planet's axis by several inches. The Cascadia subduction zone. Off the coast of the Pacific Northwest lies one of the most dangerous earthquake threats facing North America. The Cascadia subduction zone has been locked for over 300 years, building up enormous strain. Geological records show that this fault produces megathrust earthquakes approximately every 500 years. The last one occurred in 1700. When the next one strikes, it could register above magnitude 9.0 and trigger a massive tsunami. Deep earthquakes. The mystery. Below. Most earthquakes occur within the first 40 miles of Earth's crust, but some happen hundreds of miles deep within the mantle. These deep focus earthquakes defy conventional understanding. At those depths, rock should be too hot and plastic to fracture. Scientists are still trying to understand the mechanism behind these mysterious events. Journey to the center of the Earth. The deepest hole ever drilled barely scratched Earth's surface, just 7.5 miles down. Yet the core lies nearly 4,000 miles beneath our feet, where pressures reach 3.6 million times atmospheric pressure, and temperatures rival the surface of the sun. The inner core. Mystery. In the 1990s, scientists discovered something strange. Earth's inner core rotates slightly faster than the rest of the planet. This solid iron sphere, suspended within the molten outer core, is spinning at its own pace. Even more fascinating, recent research suggests the inner core may have stopped rotating faster and might even be reversing direction. The implications for Earth's magnetic field are still being investigated. Namsis. Core reversals. When north becomes south. Throughout Earth's history, the magnetic poles have flipped hundreds of times. During a reversal, the magnetic field weakens, and compasses would point south instead of north. We're overdue for the next reversal. The last one occurred 780,000 years ago. The current weakening of Earth's magnetic field has some scientists wondering if we're entering the early stages of a reversal right now. Chapriu, Snowball Earth. Around 700 million years ago, Earth experienced one of the most extreme climate events in planetary history. The entire planet froze, covered in ice from pole to pole. Ocean ice may have reached thicknesses of over half a mile. For millions of years, Earth was a frozen wasteland. Only volcanic activity, releasing greenhouse gases, eventually thawed the planet. Damkfries, the Great Oxygenation. Event 2.4 billion years ago, photosynthetic organisms began producing oxygen as a waste product. This might sound beneficial, but it was actually catastrophic for most life at the time. Oxygen was toxic to the dominant anaerobic organisms. The atmosphere's composition changed fundamentally, triggering a mass extinction. But this event also paved the way for complex life forms that could harness oxygen for energy. The Permian extinction. 251 million years ago, the largest mass extinction in Earth's history wiped out over 90% of all species. The cause? Massive volcanic eruptions in Siberia released greenhouse gases that superheated the planet and acidified the oceans. Recovery took millions of years. The event was so severe that scientists sometimes call it the Great Dying. Lashures, the ticking time bombs. Today, geologists monitor dozens of potentially catastrophic geological threats around the world. These aren't just theoretical concerns. They're active systems that could reshape civilization. The East African Rift. Africa is slowly splitting in two. The East African Rift is a developing divergent boundary where the Somali Plate is separating from the Nubian Plate. In millions of years, a new ocean will form between them. But in the short term, this process creates significant volcanic and seismic hazards for the tens of millions of people living in the region. Nafers, mega tsunami potential. On the island of La Palma in the Canary Islands, geologists have identified a potentially unstable volcanic flank. If it collapses into the ocean, it could trigger a mega tsunami, with waves potentially reaching heights of over 80 feet, devastating coastlines across the Atlantic. While the likelihood of this happening soon is debated, the geological instability is real and monitored continuously. Damshis. Subsidence and sinking cities. From Jakarta to Venice, major cities are sinking due to groundwater extraction, sediment compaction, and natural geological subsidence. Jakarta is sinking so fast, up to 10 inches per year in some areas, that Indonesia is planning to move its capital. Japriest. The living planet Earth isn't a static rock floating through space. It's a dynamic, constantly changing world shaped by forces that began before life itself existed. The same geological processes that created breathtaking mountain ranges and fertile valleys are still at work today. The ground beneath your feet is part of a system that has been operating for over 4 billion years and will continue for billions more. What we've learned. Every volcanic eruption, every earthquake, every shifting continental plate is part of Earth's ongoing story. These aren't just destructive forces. They're the mechanisms that make our planet habitable. They recycle nutrients, regulate climate, and create the diverse landscapes that support life. Understanding these processes isn't just academic curiosity. It's essential for predicting future hazards, protecting communities, and appreciating the incredible planet we call home. The unanswered questions. Despite everything we've learned, mysteries remain. How exactly do deep earthquakes occur? What triggers magnetic pole reversals? How will plate tectonics evolve over the next billion years? As our technology advances, we're beginning to peer deeper into Earth's secrets. Every discovery reveals just how extraordinary this planet truly is. The forces that forged Earth from cosmic dust are still shaping it today. We're not just observers of geological time, we're living through it. And that makes every moment on this dynamic planet more precious than we ever imagined.